Okay, now we're going to go over telemetry. You don't have an assignment with this, which I'm sure you're excited about. We are going to be using telemetry in South Africa, both at Amakhala and potentially one of the parks. I don't think we're going to get to use it at Kruger, but hopefully. Telemetry is a really important tool in wildlife research. It's incredibly important. My first study, my master's, we didn't have telemetry, 1979. So it's tough. But the amount of information and how much better information we get with radio telemetry is really superior. There's two different kinds of systems. Well, there's two different parts to a telemetry system. The first is the collar, and the second is the receiver. This receiver you would have an antenna. I didn't bother to bring that in. But this receiver, you can set it to listen to a different caller, just like you would set your radio station to a different dial. And then you listen to the frequency of that caller and you find it. You may have, I had as many as 49 radio collar desert bighorn sheep at one time. So there's a lot of frequencies to remember. They actually make a larger one that holds all the frequencies in there, which is really nice, which is what I use. And this and the antenna are your friends. This you handle once. You put it on the animal and then you usually don't see it again. So this is just a standard VHF collar. I'm going to set it right here and show you some things about that here in just a few seconds. So the transmitting system, which is your collar, and if you read the engineers, they call them transmitting systems. I call them collars. 5 components. You have your transmitter, which is down here, your antenna, which is extremely important, the power source, which is in here, and then the potting and attaching system. This is a very simple collar. You can go on to the next slide. Actually, I'm going to go on to a couple. In that, the potting system, for example, on this collar, is you can see that this part is covered by silicone. That's pretty common, especially for the animals I worked with carnivores. They're rough on collars. They go in rocky areas, they get down in caves, they might try and bite it. Another animal might try and bite it. This particular collar was a pronghorn, and pronghorn aren't very rough on collars. So therefore there's no, other than the steel case, there's no additional protection. There are 2 types of collars. This is the simple one, and this is what I got to use my whole career because I came here in 2006. I did use a few GPS collars. We'll talk about that. Great data. But this is a collar that you put on the animal, and then to find it, you've got to go find it. Then there are GPS collars, which are global positioning systems. Many of you probably have a GPS. It's a GPS unit on the collar. So and you can program that collar how many times you want to find the animal, how many times a day, what times of days you want to find it, etc. And we'll go over that more in depth depending on what you're looking for. The VHF still has some value. It still has value because it's cheap. And sometimes you don't need all that information that a GPS collar can give you. Plus, these things can go forever. Battery technology has improved and improved, and you might put a collar on it, especially a large animal that could last for 7 or 8 years. And if you only need to know where that animal is once a month, there's no reason in spending the money that you need for a GPS collar. Okay, so the collar itself is important, and here you can see this is a newer one of these that's not dirty. And you can see one that's potted. There's some different types of collar here. Some of them have padding in them. This is actually a cub collar, a bear cub collar. And you put that on the animal, you know it's going to grow. And so you put the padding on there and give it plenty of room. And this is unique in that it also is programmed to break off. You can't put a collar on an animal that's young and expect that collar not to hurt them as they grow. In the old days, instead of using these bolts, we actually use surgical tubing to tie the collar on to a young animal. And we knew that surgical tubing exposed to the weather would fall apart in about 3 months. So we would get 3 months worth of data, and that's all we needed, and we didn't want to hurt the animal, and then we'd go pick the collar up when it's off the ground. So a lot of things you need to think about before you're buying radio collars, and the cost and care associated. These breakaway connectors are really nice, really nice. They can be programmed right before you put the collar on. It used to be a real hassle, but it's much easier now. These collars are really tough material, very pliable. This is from Telemetry, which is the group here in Mesa, which I loved using. There's 6 or 7 large groups now. I liked using it at Mesa because I could run right over and get something fixed, or call somebody and ask a question. Size of the collar is important. I have put radio transmitters on peregrine falcons. I have put them on 400-pound black bears. Obviously, the size is going to really differ between the two. When I put a radio transmitter on a peregrine falcon, I knew it didn't weigh more than 4% of its body weight. When I put a radio transmitter on a big black bear, I knew it didn't weigh more than 4% of its body weight. That's the basic rule. If you're going to study an animal, though, you ought to look at who else has been studying, look at the people before, and see what percentage of body weight transmitter they put on that animal. I mean, you might be putting a transmitter into a snake. It probably can't be 40% of its body weight. So you're going to have to read the literature, what other people have done to determine what you should be using. 4 to 5% is usually the limit, though. So if I ask you, what size collar, what weight collar can you put on a 100-pound animal? You should be able to tell me 4 pounds. You want to put the biggest collar on you can. Why? Because of the size of the battery. And the battery determines how long the collar gives you information. Whether it's a GPS collar or a VHF collar, battery size is 100% important. And if that will determine how long your collar lasts. This collar probably costs $200 right now. To capture the animal and to put the collar on probably costs $2,000. You've got to figure your helicopter time, your labor, jet fuel, all that stuff. When I ran my own research projects, I mean, your budgeting was, you really had to figure out. So you want to put the collar on the animal and have it last as long as you can, because capturing them is really expensive. And it's not easy to do. It's not easy to do. So the battery size, and then the next thing you can mess with a little bit to save your battery life is how often the battery is used. If you've watched TV or you've used a radio transmitter, you know it goes beep, 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 beep. The only time the battery is in use is when it's going beep. When it's silent, the battery is not being used. So you can vary somewhat your beep frequency, or the frequency of pulses, which is the correct engineering term. But you can't do it too much. You can't slow it down too much, which would increase the battery length. But if you decrease it too much, it gets very, very difficult to find the animal. And beep, beep, beep. The way your mind works, and you have to hear it quite often to be able to tell the difference between, because what you're going to do is you're going to hone in on the loudest sound and go towards that direction. And we'll talk about this in length in the field. I don't even want to start in a lecture online. But this will help you. And solar applications, I would love it if they worked better, but they don't yet. But that's something that I think will be developed. The VHF systems are, again, it's just something that you have to go out and find. So the primary limitation of the system is the cost of going and finding it. You've got labor, you've got trucks, wear and tear, you've got gas. Sounds like somebody ran a budget, right? Which I did. But they're cheap. $200, maybe $500 for a huge one on a large animal, which is usually 1/10 to 25% of what a GPS collar. The problem is you're going to have to go find that animal to get the data. It's not going to come to you, and we'll talk about GPS and the beauties of it. You need to consider that length of the pulse, and most of these collars have what's called a mortality pulse on them. One of the hardest pieces of information to get, whether it's on a lion or a Gila monster, is why do they die? Why do they die? And so most of us that use radio telemetry have what they call a mortality sensor on it, and it's actually a little mercury switch in here. And when mercury doesn't move, it turns into a liquid, and it goes from one cavity to the next inside here, and it changes the frequency of beeps. It goes from beep, beep, beep to beep, 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 beep. So my days when I was in the field, and I averaged about 150 a year for 20 years, if I heard beep, 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 everything I'd planned to do that day had changed. I was going to find that animal because, again, the hardest information to get on wild animals is why do they die? What are the different, we know they die from diseases, we know they die from predation, but what's the percentage? So that's the hard information to get. And so almost all these collars have a mortality pulse on it. So it will go beep, 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 beep when the animal stops moving. Sometimes they don't move for 4 hours and you'll get that mortality pulse, but then it will go back to normal, and that's a good thing. But what about a species like a bear? They go to sleep for 6 months. And if it goes beep, 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 beep all winter long, which I had to deal with for years, your battery length, I mean, I could put the same size radio collar on a bear that I could put on an elk. On an elk, it would last 6 years. On a bear, it would last 2 years. And that's because of that beep, 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 beep during the hibernation period when it's not working. It's just draining the battery. Fortunately today, there's much better things you can do. Oh, one more thing that I want to talk about. Notice this big magnet. This magnet is actually used for in cattle to help get rid of iron in their stomach. But this magnet is how you turn a radio collar off. So right now, this magnet is off and this thing is beeping. As soon as I put the magnet back on the steel, it's off. So I have several collars at my house. All of them have a magnet on. And that's just something to remember. All right, GPS systems. Transmitters are designed to collect the location of the animal with you not being there. So they're wonderful. You don't have to worry about scaring the animal. You don't have to worry about your truck breaking down. You don't have to worry about hiring 2 interns that really can't find anything. You don't have to worry about stepping on a snake. You just sit there, and today they get the information on their phone, which I personally just think is wrong. But there's 3 different types. There's GPS store-on boards, although they're becoming almost obsolete. There's GPS spread spectrum, which on your notes there's SST, and I'll explain which. And then there's GPS Argo, or it should be more appropriately now, a GPS satellite. And all of them are also equipped with that VHF system, so they beep as well, and that's so you can find the collar. One of the most important reasons for you to be able to find the collar is the original collar might cost you $1,500 to $3,000. It might only cost you $500 to refurbish it. And trust me, in wildlife research, it's all about the Benjamins. It's all about the money. We don't have unlimited funding. We're not working on homeland security or cancer research. We just don't get that much money. Everything you can do as cheaply as possible. But here's a nice diagram of the GPS collar. Here you have the antenna, which is no different than the antenna on that VHF collar I was showing you. There is the GPS system. And so that is, when you've programmed it, it will look for 5 minutes where that animal is. Then you've got the battery, the transmitter, all the information, the battery, and this particular one is potted in silicone, and it's protected. Most GPS collars are potted because it's $100 and you want to protect your original 1,500. When I was buying them in 2005, they were about 3,500 to $5,000. So they've really come down in price. Okay, and now they've got GPS units down to 75 grams. So multiply 75 grams times 20, and you can get what size animal you can put a GPS unit on, and works pretty well. So they're really nice because you can program to take 6 locations a day, 10 locations a day, 12 locations a day, 1 location a day. It depends on how long you want that battery to last. Because every time that GPS unit goes on for 5 minutes, you're taking battery power. And so you need to sit down when you're designing your study and determine how often do I really need to know where this animal is. And we'll talk about, because that, or what times of the day do I really need to know where this animal is? Because the less information you collect, the longer your collar works, and the less you have to spend on recapturing or capturing. Store-on boards were the original systems, and the collars would just collect the information. It was very scary for us that use them because it would just store the information, and then when the collar fell off, remember that breakaway? The collar fell off, you could go pick it up on the ground using VHF with your antenna, and then you downloaded the information to your computer, and then you know where the animal was. Some of them collected over 5,000 data points. I had a couple friends studying elk where they were collecting information every hour because they were trying to see where they crossed roads. And you know, they had to replace, even as large as an elk is, they had to replace those collars every year because of the amount of battery use. I never liked them because it just scared the heck out of me that they weren't working. So here I am, I'm supposedly doing a research project, and I don't even know if I'm collecting data. They're cheapest, and right now it says $1,500 to $2,000. You can get them cheaper, although I just checked on that this week, and that's what they told me to average it. Sperm Spectrum units, now they're cheaper than that. I thought I changed that this morning. I'm having some real problems. All right, Sperm Spectrums were my vehicle of choice, or collar of choice. I couldn't afford satellite units. They really are only about $1,500 to $2,000 now, so that is incorrect. Please correct that on your PowerPoint. The nice thing about Sperm Spectrum units are, unlike the store on board, they're collecting data, and then you program a period of time. You have another receiver. It's different than this. It looks quite a bit different. And then you have another receiver, and you get close enough to the animal that you can upload the information to the collar and download it on the computer in that receiver. So when I was doing bears, and this was before I left and came here, I would fly and find all my bears and upload the information every 2 weeks. And I liked that. I knew I was getting information, and it allowed me to start analyzing that information in real time. I didn't have to wait for 2 years for the collar to fall on the ground. And they are the cheapest. It is expensive to buy that receiver, but once you've bought it, it's usually about $2,000, the Sperm Spectrum receiver that will talk to the collars. Although they've got the technology now that goes on. They've got receivers that talk to the collar, and you can reprogram how often that it collects information. It's really cool stuff. But that's why I liked Sperm Spectrum. Although I'll give you a word of warning. I was studying bears in the White Mountains, and so I chose a time when the planes, Game and Fish had their own planes, would not be used by other people. So I chose the afternoon. And since I was Bears are only around awake in the summertime. I was flying in the afternoon in the White Mountains, which is during the thunderstorm season. It was rough flights. I never lost my lunch, but my pilot did once. So it can get, just put a little bit of time into thinking in, when am I going to collect this information and how often am I going to collect it, because that will. Then there's the Cadillac, and this says Argo Systems, but it really, there's another company now that has put satellites up in space, that every time the satellite goes across the area of the world where that animal is, it communicates with that collar. And that collar sends that information to the satellite, and the satellite then sends that information to either your computer or even your phone. I found a mountain lion in New Mexico where the gal, all she did was, here's where the lion was 3 hours ago, and we drove to it using the GPS system on her phone. They're wonderful. But the costs start, again, I corrected that information this morning and it's not on there, but $3,000 to $5,000 per unit is a little high. They are getting anywhere from $2,000 to $3,000. The problem is, all right, now you've bought your collar, say it was $2,000. You're going to pay that satellite company. They didn't put that satellite up. They didn't get a government grant to put that satellite up. They made an investment. And they sent a rocket to space, and it cost them a lot of money. So to download your data from that satellite company, Argos, or there's a newer one that's US-based, Argos is from France, it's usually about $1,000 a year. And again, some of these might be a little more inexpensive now. Competition's wonderful for getting the price down. So if you put out 30 collars and you paid $5,000 a piece for them, there's a $150,000 layout, and then you add in another $30,000 a year to get your data. Say we assume that the collar is only $22,000, so that's $60,000 layout. It's still going to be $30,000 a year to get your data. It's not cheap, but it's going to be the best information. If you need to know where that animal is all the time, then this is the only way you can go. An animal that I studied a lot were mountain lions, and people now are using satellite systems with mountain lions to determine food habits. I use scats. I walked around and collected mountain lion scat. These people now they're monitoring their lions real time. They know where they are every 3-5 hours. If that animal does not move for a period of about 12 hours, you can bet your bottom dollar it's on a kill. There's a kill close by. What they're doing is they know where the animal is. They've got the GPS location. They put it in their GPS unit. They drive out to the area where that animal has been sedentary for 12 to 24 hours, especially if they've got a dog to help them out. They'll find that kill, and they're actually determining what that animal killed and has been eating. Be a little careful when you go on a lion kill. They get a little bit protective, but nobody's been hurt so far. Just use some common sense. But that's the cat, excuse the pun, that's the cat's meow. I mean, I would have loved to have used satellite collars. I'm jealous of people who use it today, and they are becoming cheaper and cheaper. And so I think by the time you guys, you're going to have to go to grad school before you go into buying collars. By the time you get done, it might be a lot more reasonable. Looking at finding them, it sounds simple. I don't want to spend a lot of time, especially on an online lecture, helping you use radio telemetry, so I'm going to kind of skip across this. But the one thing I tell my students is don't ever think you're really good at it, and then you'll be better at it. If you've got a sense of humility and you check yourself several times before you get out of the car and start hiking to find the animal, you'll be much better off than the person who thinks they're really great. When you're designing a telemetry study, you really need to sit down with your budget You need to figure out, all right, what can I afford? How large is my animal? Remember, it can't be more than 4%. Is the animal going to go underground? Is the animal going to go in caves? Is the animal going to hibernate? All these things are concern. For example, if the animal hibernates, I talked about how little my collar is used on bears. However, today, with today's collar, a bear biologist turns them off. You can turn the collar off, you can program the collar, the little computer chip in the collar, so that it turns off from, say, November 15th to March 1st. No data is being collected. Well, you don't want any data collected. You know where it is. The bear's not moving. Why do you need data being collected? To save your battery. There are people who are only looking at animal habitat selection at night. Turn it off during the day. If you're only looking for diurnal habitat selection, I was doing diurnal bedding habitat of black bears. Why would I need it at night? I don't need it. It saves my battery. I don't have to recapture another bear. All these things you have to consider. The length of time in between GPS fixes. Obviously, just like the beeps, the longer in between GPS fixes, the longer your battery uses. So if you need to find the animal every hour, like you want to know exactly where it's crossing the road, you can just bet on your collar's not going to last long. But if you can go 7 or 8 hours in between, then you can get a lot longer period out of your battery. And you might turn it off for different periods. It's getting crazy what people can do now, and I'm jealous, but then again, I'm not jealous because they do all of it from their office and not in the field like I was. But they're going to collect much better information than I did. So you need to figure out your variables measured, your spatial data, and your time data. And time can be important. I don't want to go into habitat use studies too much right here, but if you're actually looking at habitat use and you find the animal every 4 hours with a GPS collar, the habitat that it was found in 4 hours ago is not independent of where the habitat is. It was found this 4 hours and maybe the next 4 hours. Animals don't move that much. So you have to consider the amount of time in between sampling and making sure that each observation or each location is independent. And there's actually books written on this, on how to do it. Way beyond what we're talking about here. Just be aware that if you're going to do a habitat use study, and I'm working with a graduate student now on our garter snakes, and I'm trying to help her make sure we're collecting as much information as we can now to know how often they move, and then we can determine how often she needs to find them. Because she's only using VHF because you can't have a GPS unit on a snake. So you need to look at your sample size as well, collar cost and type. One of the things that you need to think about too that can happen is, I don't have a GPS collar with me, but remember that GPS unit sits right here so it can see the sky where the satellite is. If that animal goes in a cave a lot or a burrow a lot, you're not going to have a lot of data. So is the GPS the best way for you to go? There's a lot of things to consider. And really what you need to do is somebody who's studied like 14 different species of mammals, and then you get into lizards, it's 32. You have to read the literature a lot. You have to see what other people are doing, what problems they've encountered. You're going to do a mini study in South Africa, you're going to see this is a lot more difficult than you think. How reliable is your data? Fortunately, GPS collars are much more reliable than the old way. When I found daytime beds for bears, I would literally go out, radio track. When I started to realize I was close just by the amount of audio, the volume got loud, I would do a circle. I'd do a 360-degree circle and keep pointing the antenna and finally realize where I thought that animal was, then flag my way out, and then come back in the next day after she'd left and find where she was laying down. It's pretty easy to determine where a bear had bedded. Today's GPS unit, you know where she is within 10 meters. You just walk there the next day, boom, you've got it. Costs are going to be really key. It's really going to depend on which cost and how much. And so on a take-home exam, I reserve the right to make you think about that. These are just some of the best sources for equipment. This first website just gives you a list of all the different telemetry equipments. These are the three. Telonix is here in Mesa. AVM has a good reputation. Low-Tech has a good reputation. Be aware that, you know, wildlife science is not a major industry. We don't have a lot of money. And so these companies are somewhat working on a shoestring budget. So if you hear that some new company has the greatest and latest and can do everything, tell the temperature, tell the heart rate, record it all, deliver it to your phone, be skeptical. How long have they been in business? Talk to somebody who's used their equipment. How many of them failed? Because when GPS started coming out, my first time I used GPS, over 50% of the collars failed. We were paying $5,000 a piece. So how expensive is your data collection going to be? Oftentimes, especially with Sperm Spectrum, because I did quite a bit of modeling on this to determine my budget, Sperm Spectrum collars are cheaper than having someone out there finding it all the time. It's expensive to have somebody out there in a truck bouncing around on roads. Trucks break down, gas is expensive. People can't find the animals near as much as we thought we would. So Sperm Spectrums often are cheaper than having a person, but then you're paying $1,000 a collar. Can you afford that? So let's just look at some examples. Here you've got a mortality study of mule deer on a winter range. All I want to know is when and why did the animal die? Okay, I don't need to know the location until the animal dies. So all I need to do is go out to my winter study area and turn each frequency on and listen. And if I don't hear a beep, 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 I go right back to home. All right? I don't need a GPS collar for that. I can use a VHF collar. I can save a lot of money. I don't have to spend tons of time in the field. All I'm looking for on something like a mortality study, and if you just want to know what percentage of them died, you don't even need to know the day or the why. You can sample once a month. You can go out to the winter study area every winter. I'm going out once a month and I'm listening to what's dead, what's alive. I go find the dead ones. All right, they died. 3% of them died this month. 4% of them died that month. There's no need for an expensive GPS collar. If you want to do a migration study of bald eagles, you better get a GPS unit because you ain't following that eagle. It flies a lot faster than you can drive or walk. So GPS is the only way to do something like that. Caribou habitat study. I don't know how much you know about caribou. They move 100 to 200 miles a day sometimes. In an Arctic tundra where there are no roads, you're not going to go find them. The only way you can find an animal like that is with a GPS unit. Habitat selection of Gila monsters. Can you put one of those GPS units on the outside of a Gila monster? Especially an animal that spends 95 to 99% of its life underground. It's a waste of time. Use a VHF transmitter. You can't get the data anyway. Locating bat roosting sites. Interesting problem here. You got a very small animal. You cannot, 75 grams is bigger than most bats. So you can certainly not put a GPS unit on them. So you're going to have to go VHF. And it might only work for 3 weeks because your battery is so small. But so you got to be on it. If you're monitoring movements of a bighorn sheep transplant, it depends on how often you need to know how long they moved. Is flying once every week, which is what I did with 10 different transplants, was fine. Gave us all the information we needed. Didn't need a GPS unit. But if you really want to know what's going on, today, with GPS units going cheaper and cheaper, I've got two friends monitoring a couple transplants. They've got GPS spread spectrums on them. They go out, they fly every other week. They know where their animals were every 5 hours. Got a lot better information than I did, a lot more. They know a lot more about what those sheep were doing than I did, and I would prefer that. The last thing I want to touch on before and that's how often you take data. with a GPS unit. And again, I keep picking up a VHF collar. When I collected data on bears, I collected data every 5 hours. And then if I was going to change that, I collected it every 9 hours. Notice that I'm picking odd numbers. If you select an even number and you say, okay, we're going to start it at 8 a.m. and we're going to collect data every 4 hours, you're going to be collecting data at 8 a.m., 12 noon, 4 p.m. every day. Every day. It's never going to change. It's not going to change in the winter. It's not going to change in the spring. It's not going to change in the summer. It's going to be every day. If you do an odd number, you're going to continue around the clock. You're going to continue around. One day it'll be 8 o'clock. The next day it's 9 o'clock. The next day it's 10 o'clock. Next day it's 11 o'clock. You're going to have better information, more, all day long, 24-hour information instead of 4 times, the same 4 times every day. Use an odd number. And that's it with telemetry. And I hope we get to find some cool animals in Africa.